Hey everybody, it's Mrs. Mitchell. I want to work a problem with you today that talks about investing. Sometimes in the future, hopefully, you will be given a small amount of money or maybe hopefully a large amount of money, and you want to know what's the best thing to do with that money. Today we're going to work a problem about someone who got some money for their high school graduation and they're trying to decide what to do with that money. Of course, you might want to take a vacation or put that money towards a car, but in reality, what is the very, very best thing that you can do with that money? So let's look at what this girl in this problem decided to do. Okay, I'm going to set my camera up. All right, here's my problem right here, and hopefully you will be able to see the words relatively well, but I'm going to read it to you, and then I'm also going to work through the problem, okay? This problem says that Kelly plans to put her graduation money into an account and leave it there for 4 years while she's attending college. She receives $750, so I drew a box around that because we'll need it, that she puts into an account that earns 4.25%, which I already put a box around, that is compounded semi-annually, that I also put a box around. How much will be in Kelly's account at the end of 4 years? So I went ahead and drew boxes around the material that we'll need. And here's Kelly's money, her 750 Monopoly dollars. Except this only works with real money in a real bank. So anyway, I want to show you what happens to her $750 if she chooses to invest it as opposed to go on vacation or have a big party. So let's lay our 750 bucks over to the side. The first thing that you want to do on a problem like this is have the correct formula. There's a formula for finding compounded interest, and that formula looks like this. A, which will just be that final dollar amount that you're looking at, A equals P. P is your principal, that amount that you started with, okay, times 1 plus R over N, where R is your interest rate and N is the number of times that money was compounded annually, the number of times the interest was compounded annually. And then you're going to raise that number to the N times T power. Again, N means the same thing. N is still focused on how many times did that interest get compounded annually. And T is the time. How many years is it actually there? Okay, so the first thing we need to do is just start plugging away our numbers here. So we have A equals, remember principal or P is that original amount of money. So in our problem, what was our original amount of money? It was actually the $750. So I'm going to highlight that right here so you can see it. $750. I'm going to take that $750 and substitute it in for the P. So $750. I'm just going to put $750. I'm not going to put $750. Times, and now I'm going to work on the rest of it. 1. The 1 is constant. There's nothing to substitute in there. That is a constant number. Plus, all right, now we're looking at our interest rate, which is the R, because we want R over N. So here's my interest, 4.25%. Now, I can't just substitute in 4.25. I have to change that to a decimal number, not a percentage. To do that, we move our decimal point to the left 2 times. That's the new decimal, and you add a 0 as a placeholder for any of the decimal points that you moved it over that need filling in. So our number, our decimal number, now becomes 0.0425. That's our decimal number. It's a decimal as opposed to a percentage. Over N. Remember, N tells me how many times was this thing compounded. And if you might have to go reread the problem, but you'll see that it's semi-annually. Of course, the phone rings when I'm right in the middle of doing something, so I turn it down, maybe you won't hear it. So back up in the problem, find where it says how often it is compounded. In our problem, it's semi-annually. So you need to know, what does it mean to be compounded semi-annually? Well, that means twice a year. So our N is 2. Okay, close your parentheses, and now we're going to work on that exponent. The exponent is N times T. N, again, is that number of times that this was compounded annually. semi-annually or twice. So I'll put a 2 for the N times how many years? Well, that was the very last thing that it said, 4 years. So I'll use a 4. So I've got 2 times 4 for my exponent. So now everything's substituted in. All we have to do now is follow the order of operations and simplify this thing. So I'm going to start by saying A equals, the 750 will be the last thing we take care of. 750 times 1 plus, I'm going to go ahead and multiply this bad boy out. So I've got my calculator over here to the side. I don't know if you can see that or not. 0.0425 times, or I'm sorry, I need to read my problem. 0.0425 divided by 2. So I'm just going to put that in my calculator. 0.0425 divided by 2. And I get 0.02125. 0.02125. And I'm going to raise that to the 2 times 4 is 8. So I'm going to raise that to the 8th power. Okay? Now, keep it on. That's all I can do on that line. So I'm going to go to my next line. A equals, I'm still leaving Mr. 750. I'll get him later. I'm going to add 1 plus 0.02125. Well, that just is 1.02125 to the 8th power. So in my calculator, I want to make sure that I don't forget to add the 1 plus 1 equals, so that I have the 1.02125. Now I'm going to raise all of that to the 8th power. So I'm going to hit my little caret key. I don't know how your calculator is, but on mine I have a little button right here that looks like the button when I hit Shift 6 on the computer keyboard. It's what we call a caret. So I'm going to hit the caret and the 8 and equals, and that tells me my number. And I got 1.183195628. Now I'm not going to write all of that down. Whoops. Hold on, somebody IM me. It popped right up in the middle of my screen. I can't see what I'm doing anymore. There we go. Sorry about that. But I am going to write part of that down, and I'm actually going to leave it in the calculator exactly like I had it to begin with. So I'm just going to write 1.183 just to remind me if I have to go back and check or rework that that's the amount that I was looking at. Okay, I'm going to slide that up a smidge. Now that I still have this whole number right here in my calculator, 1.183, while the whole thing is there, the 1.183195628, I'm going to multiply it by 750. So times 750. And that tells me that my A is equal to, now I am going to put my dollar sign here because we're talking about money, $887. And it says 0.396, but since we're talking about money, I'll round. So that would be 40 cents. $887.40. And you're done. So that means if you took your $750 that you collected from your graduation money and you invested it at a bank that compounds their interest twice a year, and you left it there for 4 years at a rate of 4.25% or 4.25%, you would no longer have $750 at the end of those 4 years. You would have $887.40. So some of you may be thinking that, well, gosh, $137, that's not that much difference. But you didn't have to do anything. You made $137 and some change simply by letting the bank use your money. So, I mean, I know that if somebody walked up to me today and handed me $137, I believe I would take it. So anyway, my point is that over time, your money can multiply, whereas if you had just spent the money, you wouldn't have any left, much less have made another $137 and change. So anyway, that's just an example of compounded interest and how it works. If you have any questions, make sure that you come to lab or math support, whichever one works for you. And also open office on Friday mornings, and your teachers will be so very happy to help you. So I hope that this helped you a little bit with compounded interest, and I hope you have a great day. See you soon. Bye. I had to get it where I could see it. Bye, guys. See ya.